Hello everybody, today I'm going to prove that the momentum is real. So first of all, let's define momentum. Momentum, actually no, before that we have to say that momentum is equals to the compass conjugate, because of course it's real, the compass conjugate are going to be the same. And in order to do this, we can say that one minus the other is going to be equals to 0. Okay, so let's start it. The momentum is defined to be what? Well, the integral of the compass conjugate of our function psi times the momentum uh, operator, which is equals to negative I h bar times the derivative in terms of x of our psi dx. And our momentum, the compass conjugate momentum will be the same thing, just compass conjugate on top. And we can rewrite this as IH, and we change the sign in front of the I because it's a compass conjugate. And then inside, we change the compass conjugate becomes the simple function, and then the derivative in terms of x, or our function becomes the compass conjugate dx. All right, so we put one minus the other, so we take this and we say minus this part over here. Okay, so let's rewrite a little better. So we have a negative IH in front, and then we have the first one, our compass conjugate function, and then derivative in terms of x, or compass conjugate dx, minus IH bar again, the integral. What are the boundaries? But I'll put in a second. I want to write them over and over. So our function, and then the derivative in terms of x, or compass conjugate dx. And one thing that I want to do is now factor out the I h bar. So I have I h bar that multiplies the compass conjugate, sorry, the integral of, well, I have what? Well, one thing we can look at is that these two together, let me change it to blue because we're annotating on the side. I'll duplicate and put it over here, change to blue. Add it together, because it's like we were adding it together, is equals to what? Well, it's equals to the integral, and then the derivative in terms of x of these two multiplied. Let me do this. Because if you remember, it's like saying, it's like using the chain rule for the derivative in terms of x. So we can rewrite it with this trick. And so we're just going to have negative IH bar, then derivative on this in terms of x, compass conjugate on its normal, dx. The derivative, of course, is going to go from negative, the integral is going to go from negative infinity to positive infinity. And so, as you can see, I'm gonna derive this in terms of x, and then I'm gonna integrate this in terms of x again, which means that I'm just gonna go back to this value right here, and the only thing I have to do is plug in my boundary. So negative IH bar, and then my psi compass conjugate that goes from negative infinity to infinity. And as we know, our psi approaches 0 as x approaches plus or minus infinity. Therefore, here we get 0. And that's exactly what we're trying to prove up here. So our proof worked.